Okay, so on number 1 here, what are we going to do to fill in this table? Okay, so we're going to plug in our x value, but look, it's 3 to the x value. Now, the process is actually plugging it in by hand. So 3 to the x here represents -3. So it's 3 to the -3 power. And what is 3 to the -3 power?
0.3.
Yeah, go ahead and let's do it as a fraction. So watch. Second, quit. So we're going to do 3 to the power of -3. And you should probably get a decimal, right? I want you to change it into a fraction. How do we do that? Math, enter, enter. Boom. 1/27. Okay? 1/27. So the actual point is at -3 is our x value, comma, 1/27. Okay? So 3 to the -2. Where's that at? Change it into a fraction.
1/9.
1/9. Oops. Is anybody seeing a pattern? Okay, so here's the, do y'all remember the exponent rule when you have something to the negative exponent power of a negative exponent? Everybody remember what you do? Bring it to the bottom and it becomes positive exponent in the denominator. So really this just means 3 to the -3rd just means 1/3 to the +3rd. And 3 cubed is 27. So that's where this comes from. Okay? So 3 to the -1, 1/3. So -1, 1/3. 3 to the 0. Okay, anything to the 0 power is 1. 1, 1, 1, 1. Try it on your calculator if you don't believe me. So 0, 1. Okay? Then we have 3 to the first 3 to the first power is 3. So this would be at 1, 3. And then we have 3 to the second power.
9.
That is 9. So that is 2, 9. Very good. Any questions on that table? Okay. Now what I want you to do is take the last column here. Those are all points. I want you to graph that right here. We have -3 and 1/27. So clearly -3, 1/27 is pretty much like right on the axis, right? Because 1/27 is really, 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 really little. It's really close to 0, but not quite 0, right? -2, 1/9, still really close. -3, I'm sorry, -1, 1/3, so maybe just a tad bit higher, right? I'm sorry, 0, 1. So it's starting to curve. Yes? Okay. 1, 3. Now it's really starting to curve. This is the exponential growth. And 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I'm going to do my best to draw a curve, but it's kind of hard to do this with. Not bad at all. Oop, just kidding when I said that, and I got ugly at the end. Okay, so this is kind of how it's almost flat here, right, at the bottom, and then it starts to curve and rapidly increase right here. It's really ugly, but you get the idea. Okay. In the exponential functions box, this is the form you will see exponential functions written in. Y equals A times B to the power of X. Y equals A times B to the power of X. So in this previous problem, we just had Y equals 3 to the X power, didn't we? Yeah. So we didn't really have an A. We had this. What was our A, you think?
0.
It was a 1. Because if you had a 0 there, it would 0 times 3 to the X power would be 0. But 1 times 3 to the x power is just 3 to the x power. So if you don't ever have an a, it's an understood 1, okay? And let me tell you what each of these mean. What do you think the b means, or the 3? What was happening here that maybe could tell you a little bit about the 3?
It's getting higher.
It's getting higher, right? Keep going.
And higher by 3.
By multiplying by 3? Are we adding 3? Are we multiplying? Are we dividing? What are we doing?
Dividing.
1/27 times 3 is 1. Dividing by 3 is 1 9? Multiplying. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 would be? Okay. So this right here, your b value will be your multiplier, or your what you're changing by, almost like your slope, but it's not plus something, it's times something, okay? What you're multiplying by, okay, is your b value. So if I were doubling something each time, my b value would be 2. Okay, the a value is a 1. Where do you see a 1 in here? There's 2 places. But yes, this right here is, ooh, hello. This right here is what I'm talking about. The 1 is where our x is 0. So basically our y-intercept is our 1. Okay? So our a value is our y-intercept, our b value is what we're changing by. Okay, so here's this exact same function we were just working with. Is f of x an increasing or decreasing function? So from left to right, is it increasing or decreasing? Increasing. Okay. What's the y-intercept? 0, 1. It's an actual location with a point. Find the value of x where f of x equals 0. So f of x means y equals 0. So interesting. Let's go up here. Where does our f of x or our y equal 0? Do you see a 0 on here? So does it ever hit 0? No, this is a trick question. From yesterday, remember I talked about it gets closer and closer and closer to the x-axis? What did I call it yesterday? Approaching x. Good. We're approaching the x-axis. Does it ever touch the x-axis? No. So this is kind of a trick question. When will it equal 0? When will y equal 0? Never. Or you could say does not exist. DNE. Does not exist. It will never be at that point. Okay? What? Okay, find the average rate of change between 0 and 1. X equals 0. It was at 1. And x equals 1. It went to 3. So what was the rate of change there? How much did it change by? Yeah, it added 2. Okay. What was the average rate of change between 1 and 2? So at 1, it was at 3. And at 2, it was at 9. So how much did it change there? Okay, rate of change, it's talking about how much you're adding by, okay? But yes, the multiplying by 3 is your multiplier right here, your b. If it asks for rate of change, it's kind of talking about slope, so you'd have to add, okay? Domain of this function, okay? Let's look at the picture. How far to the left does it go? Forever. This is an arrow. It doesn't stop here. Can I keep going and going and going? How far to the right does it go? It keeps going even though it's getting steeper and steeper and steeper. It keeps going to the right. So what is our domain? All real numbers, yes. What is the range of this function? Up and down, bottom to top. How low does it go? Does it ever touch 0?
No.
But it's everything above 0 and up, right? So how would we write that? y is greater than, not greater than or equal to, right? Because it never touches 0. So we can't put the equal here. It's just y is greater than 0. That's the difference between exponential and quadratic when it was y is greater than or equal to 0 with a quadratic. Okay? Y'all with me? All right, now I want you to try this new equation. F of x is equal to 2 times 3 to the x power. 2 times 3 to the x power. So what's changing? What's different between this one and this one? The a is different. Where was the y-intercept here? 0, 1. Where's the y-intercept here? 0, 2. I don't even have to plug it in to know that, because I know that a is our y-intercept. Okay, if you were to look at your graph and plug this into y equals, so 2 times 3 to the power of x, and then press graph, you could see the picture of it. Is it increasing or decreasing? Still increasing, right? But where's the y-intercept now? 0, 2. It's a location. Make sure you write the point, okay? So it's still increasing. Now the y-intercept is at 0, 2. Does it ever hit 0? Does y ever equal 0? No. So our answer is the same here. Either we can write never or it does not exist. Okay. What is the average rate of change between 0 and 1? Okay, this one we're going to have to look at the table for that, right? So go to your graph, look at the table. Okay, between 0 was at 0, 2, and at 1 was at 1, 6. So 2 to 6 is how much of a change? 4. Good. Okay. And what's the average rate of change between 1 and 2? So 1 is 6, 2 is 18, so 6 to 18 is 12. Good. It's still multiplying by 3 though, isn't it? If you looked at your table, 2 times 3, 6, 6 times 3, 18, 18 times 3, 54. See how the change, the 3 is still the same, the b value? Yes? But where it's starting, the a value is different. What is the domain of this function? If you looked at our graph, it's still all real numbers, going forever to the left and forever to the right. And what is the range of this function? It's still greater than 0. It's still not touching 0, and it's still above it. Okay? Okay, well, we already did number 3 because we've already graphed it. Predict what would happen if you graphed this function. What was the change that you saw? What did you say? Okay, so you said the y-intercept changes, right? So it was originally at 0, 1. Now it's at 0, 2. So basically it's looking like this. Oops, does it cross? So if you were to describe that, what would you say it did? It shifted up. It just shifted up 1 unit, didn't it? Kind of like when we change our y-intercept on a line, you're just shifting up. Or the c value in a quadratic, right? You shift up or shift down. Why are you laughing? Okay. So, so we would just describe this as it would shift up 1 unit. Because the a value was originally 1 and now it's 2. So what do you think would happen if we change it to a negative 3x? I'm sorry, negative 3 to the power of x. Okay, well, let's see. So negative 3 to the power of x. Okay, so what did it do? It reflected, and it is now decreasing, yes. So I heard a couple of you say that it was going to reflect. Complete the table below. Well, I guess it's on the next page. Okay. So now we have two different equations. Okay, before we graph it, let's go ahead and fill in this table part first. What's the value of b for 4 to the power of x? 4. What's the value of a? 1. If it's not there, then it's always an understood 1. So this is the same thing as 1 times 4 to the x power. Do you think it's increasing or decreasing? What's the y-intercept? Say it as a point. 0, 1. Oops. 0, 1, because of our a value. What's the domain, you think? What do you think the range is? Okay, so let's check this out and make sure we are correct. So we're just going to graph it. Okay. It should curve up if we're right. Good. It's increasing. And let's look at the table. We can get some pretty points to graph. Okay, 0, 1. There's our y-intercept. 1, 4. So 0, 1, and 1, 4. And the next one's going to be off the page. It's going to be like up here somewhere, right? So here is... Oh, that's ugly. It's really hard to do this with a... You get the idea, right? Okay. All right, and the next guy, it's a little different. What's the value of b here? Still 4. What's the value of a? I'm going to change colors. 0.5 or 1/2. Is it increasing or decreasing? Let's check. Oops. 0.5 times 4 to the power of x. Is it increasing or decreasing? Still increasing. We didn't change our b. We only changed our a. What does our a change again? Shifting up and shifting down. So what is the y-intercept here?
0,
0, 1/2. So basically it's the exact same graph, except for it's just slightly lower, isn't it? Ugh, so ugly. Because the original one was at 1, and this one is at 1/2 for the y-intercept. So it's just shifting down how much? Half a unit. Yeah, 0.5. Is the domain and range the same? Yes. It's the same. Okay, so how did these two graphs compare? What did we just say was different about them? Yeah, this one shifted down half a unit, right? Good. So when we change our what value, is it shifting up or down? Our a value. If we increase our a value, it's going to shift up. If we increase our if we decrease our a value, it's going to shift down. Good. Okay. All right, we have another one where we have to do the process. So we're doing 1/2 to the -3 power. What is that, you think? Make sure you put the 1/2 in parentheses if you're going to do this in your calculator. Like if you're going to do 1 divided by 2, make sure you put it in parentheses. And then to the power of -3. Ooh, that's kind of interesting. Why is it a big number, not a small number, you think? But before, when it was a negative, it was a fraction. Anyone? Anyone have any thoughts?
Multiplying a half by half and then multiply by half again.
No, it actually becomes smaller. But good try. Yes?
You bring the 2 up.
Yeah. You bring the 2 up because of the negative exponent. So this really means because it was negative, this whole thing is, remember you have to bring what's in the bottom to the top and what's in the top to the bottom. And then once you do that, it becomes a positive integer. So, what is our point value here? What's our coordinate? -3, 8. Okay. What is 1/2 to the -2 power?
-1.
Try it. 4. Because it would mean 2 over 1 squared, and 2 squared is 4. So this would be -2, 4. What is 1/2 to the -1 power? 2. This would be at -1, 2. What is 1/2 to the 0 power? 1. So 0, 1. What is 1/2 to the 1 power? 1/2. Yeah, 0.5. So 1/2. And what is 1/2 squared? 1/4 or 0.25. Okay. So let's go ahead and plot these guys. -3, 8, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. -2, 4, 1, 2, 3, 4. -1, 2. 0, 1. 1, 1/2. 2, 1/4. And that's going to keep going, right? So how does this one look different? Is decreasing instead of increasing. What do you think about our function here is making it decreasing? I don't see a negative anywhere. The fraction. What about that fraction? Oops. Because it's less than what? It's less than 1. If your b value is less than 1, it's going to decrease. Okay. Just like over here, I guess it was back on the other page. Oops. Hello. I don't know what that was. Get off my screen. When you had the negative b value, it reflected. That's less than 1 as well, isn't it? And it was also decreasing. Okay? So a lot of this you can just discover by plugging in your calculator and looking at the picture, right? It's not like I'm going to take that away from you and you're not going to get to use it. So what is the y-intercept of this graph? 0, 1. So right here. Find the value of x where f of x equals 0. Nowhere. This never happened. So it does not exist. It never touches 0 on the x-axis. Y does not equal 0. Is this an increasing or decreasing function? Decreasing from left to right. What's the domain? Still all real numbers. What's the range? It's still y is greater than 0. Even though it's decreasing. Okay, so in summary, what have we learned about the b value? What does our b mean again? The multiplier. So what happens if our b is between 0 and 1? So it's less than 1. What's it going to do? It's going to decrease. Just like the previous problem we just did, where it was 1/2. Okay? What's it going to do if b is greater than 1? It's going to be increasing. And if it keeps going higher and higher, it's going to increase at a more rapid pace. Okay? All right, the A. What did the A mean again?
Y.
The Y-intercept. Good. Where it touches the Y-axis. What if the A was less than 1 but greater than 0? Yeah. Really anything that's below 1, right, was going to shift down. Okay, what happens if it's greater than 1? It's going to shift up. Okay, if anything is ever negative, so it's less than 0, what do you think is going to happen?
Reflex.
It's going to reflect. Good. Okay, and that is it.